Here in front of us today is a Chevy 10-bolt rear end. This 10-bolt came out of a 1980 Chevy Caprice, and it is an 8.5 corporate rear end. We're going to be fully rebuilding this entire rear end from start to finish. This whole procedure applies to all 10-bolt and all 12-bolt models. We have a few previous videos of rear ends that we have rebuilt, 10 bolts and 12 bolts the like. Those videos will be linked down in the description below to our other channel, ZHP Garage, where you can check out those videos to see how we put those rear ends together and also put them into the car. But for now, let's get into the rebuild of the Chevy 10-bolt rear end.
So today we are going to be building a 10-bolt rear end. This is already tore apart because I narrowed it. We shortened the axle tube and then welded new ends on it to fit under older Chevy with wider tires. And then I welded the inner tube here to the center for two reasons. One, to help seal it, because you can get a little bit of leak through there, and then give it a little more strength where it goes into the center there. So you can see we don't have any brackets on here. The other person started to cut the brackets off, so the housing got a little beat up, but it should be okay. We're gonna add the brackets. It's gonna be a leaf spring car, so we're gonna add that after it's all built. So I'm gonna start this whole job building the rear end by putting in the races in the housing. So I guess you would call it the outer pinion bearing would be here, and then it has a pinion seal, and then the yoke, and then you have the inner pinion bearing. So we're gonna get them both knocked in. So I'm gonna make sure my race, this is a new race, put all new bearings in it. So make sure we're all wiped clean. And then I already blew the housing out and cleaned it all up, and just make sure there's nothing there. Everything's nice. And then you don't want to put this in metal to metal dry. Yes, it'll go in, but it'll kind of grab as you're beating it down. So I like to get this extreme pressure lube. It's like a machinery lubricant. And I like to just put a coating on the outside of it here. And you don't need to get crazy with it, just to film. You can use engine oil, any sort of lubricant would work out. It doesn't need to be a lot, just so it's not dry. And then the chamfer part of it goes so you put the bearing in it. So make sure you don't put it in upside down. And then I have an aluminum driver. This is a race / seal driver. So because this is aluminum, it doesn't put any marks or anything on here, but you will get a little bit of the aluminum once you beat it in, so you're gonna have to wipe it and clean it up. So we're just gonna drive this down nice and straight. If you're going crooked, come over to the other side. You see it changes pitch there. It's all the way driven to the bottom. It's nice and solid. Then we're just gonna make sure, clean up any aluminum or any of the extra lubricant that we use to drive the race in. See, we get a little bit of aluminum on there from our installer. Nothing crazy. Rather have that than mess up your bearing race. So same thing. We have our race lubed. I changed the adapter on the installer here. Put our race in here. And this one's kind of tricky because I have a shorter handle on here, but there's enough room. Do the same thing and just drive it in straight. There it is. Nice and solid. Same thing, wipe it up. Make sure we don't have any aluminum from our installer on there. So now we're gonna go over and we're gonna prep the pinion bearing. So here we have our new ring and pinion. You don't wanna ever put this bearing on without a shim in here. There's always gonna be a shim in here. But being that this was already taken apart, we couldn't measure the pinion depth before to have a reference. These gears have a number on here, which I believe is this number, is your pinion depth. So I do have the old shim that was on the old pinion. I don't like this because it kind of moves more than I think it should. This is gonna be pressed on. It still has the chance of wobbling on here and cutting into it. I'm going to start out the same thickness of this shim. So we have caliper here, got it at 0. My battery's going dead, so it's going to blink at us. So if we measure this one, the shim is 37.5. We'll call this 38 thousandths. So I have the new shims here set up. They don't have one the same thickness, but we have in 3, we're able to achieve the same thickness, 38 thousandths. And these shims, you can see with them on here, that they fit snugger than this one does. So I kind of like that. So I like how these don't flop around quite as much, and it has a little more surface area, so the bearing sitting more on a solid surface than all this gap. So we have our new pinion bearing. So we don't want to go this way with it. We want to go this way because it's going to sit in our race. So we're going to put some lube on the inside here, and then we're going to press this on here. So we're going to put our lube in here. Then we need something to drive this on, or you could flip it if you're doing a press. But the way I do it is I have this special tool here that's designed to do this, so it'll go over the pinion, and you want to push on the race part of the pinion, not the cage. And then I'm just going to take it over here. I'm just going to drive it on with a hammer. So I'm going to set it on something solid here, which is my vise. We already have our shims on there, so we didn't forget our shims. So we're going to hold the tool. We're going to make sure we're centered up on our race. Just drive it down. Keep an eye on it as we go. I'm going to cheat. I'm going to switch over to the press. So if you didn't want to beat on it, then you can always press it. When you're pumping this, it's more of a feel that you feel it get hard. So now we got it all the way seated on there. So now you can see we have it fully seated up against our shims. So now we have our pinion bearing all the way on there. So we're gonna wipe off our excess lube here, clean this up a little bit. And this lube, I mean, you don't need to worry about it contaminating or anything with the gear oil. It's not gonna bother anything. So now we're gonna install the crush sleeve, and that's what's gonna put tension on it with the outer bearing. But first we gotta put it in the housing and then put the bearing on there. So now we're back over to the rear end housing, and then I wanna leave these dry, because the measurement of your rotating load is with a dry bearing. If you have anything on here, it could change your reading. Make sure this is clean and dry. We're gonna flip it up, same on the other race here, just double check it, clean and dry. We're gonna take our bearing and we're gonna set it in here. And the way I like to do it is I take a little brake cleaner here, and then now the seal is gonna sit here. So I like to make sure that the seal surface is clean and dry. I like brake cleaner because it dries, no residue. Then I have my pinion seal that I put some trans gel in the back of it here to make sure that my spring, I've seen people have problems with the seal. It could be a cheaper seal, but the spring comes off when they put it in. So just as a safety precaution, kind of holds the spring in there. So then I'm gonna set the seal in here, and then I got my driver here, I change the size of it, and even though it has a bolt, there's nothing in the middle, so I'm not worried about hitting anything. We drive the seal in nice and straight. And then this is the actual, it's like silicone kind of, it seals the seal in the housing. That shows you have a good seal is when you get that come off like that. You can use grease, anything, just a little lubricant on here. You don't want a dry seal. Okay, then now we have our pinion. So this bearing is gonna sit right here. That bearing is being pressed on here, so it's gonna be a tight fit. So we're gonna put a little bit of our lube on here, kind of help it go on. So this bearing, like I said, is gonna go up against this crush sleeve, and that's what gives you your preload. It's possible that you can get a little bit of fluid leaking from your splines. So on the pinion yoke, I'm gonna take a little silicone, any silicone, whatever you like. This one here seems to work pretty decent for rear ends. Put a little silicone on the inside. We don't want it leaking around the splines. Get it evenly spread. Got some on all the splines. So this is gonna go up against our pinion bearing right here, the race. So we don't want any silicone squishing out of there. So make sure that is wiped off. So I'm gonna put the bearing, or the whole pinion, up in the housing here, and it's gonna start trying to push the bearing into the seal. We don't wanna push it into the seal. So now we're gonna put our pinion yoke on here, and the goal is we put this on, work that around the seal. So I have two different washers here. So this washer is the original washer, and this is the one that comes in the kit. You can see how much smaller the washer is, and even how much thinner it is. If all possible, I like to use the original one. So I see how it takes up all the surface area. So that's a good size washer. And then normally the nuts that come in the kit are pretty cheesy, but this is a nice beefy nut. I got the little fastener lubricant here, the ARP. So I don't want the nut to grab and do any galling or anything as I'm tightening up the nut. I'm gonna put some on the washer, only on the side that the nut is gonna be on. We'll set that back in there. Then I'm gonna take a little bit and I'm gonna put it on the threads of where the nut's gonna go. And you don't need to put Loctite on here because this is a lock nut. So that's why we're able to put lubricant on here and it's not gonna affect anything. Now that I have my nut prepped, now we're gonna put it back in there. If your nut won't catch, tap this down. So now that I got a couple threads on there, I got my socket, I'm gonna bring it down with the impact. This is the fun part. I want to give you a comparison really quick. This nut is the original nut, which is actually a little bit thicker than some of the aftermarket ones that come in kits. But just to give you an idea of this is actually a good sized nut, you want to have a good sized beefy nut and washer if all possible. It's nice to have an impact at this point. So you run it down and it gets, it's hard because you're pressing that bearing onto the pinion. But then it gets to a point where it gets really hard because now the bearing is up against that crush sleeve. So this is already really tight. You can see, we're close, but we still have slop. So we're trying to achieve 25 inch-pounds of rotational torque. So we need to crush down the crush sleeve a little bit more. We're gonna go a little more and we're gonna check as we go. This is why it's the fun part. It seems to always tear up my hand no matter how many times I try. Try not to. So they make a tool. It's kind of hard with the rear end out of the car, but they make a tool that would go on the pinion, and then you have to use a long breaker bar if you didn't have a torque wrench. And that's what makes this really the hard part of the whole job. So you can see that we have our slop out of it, and we're starting to get a little bit of rolling resistance. So if we check now, I don't think we even have enough to move the gauge. We're just starting to come into preload, but we want to get it up here to 25. We're going to do a little more. And I like to use the hole in the socket as a reference. I'll keep an eye on it, and then I'll bump it and then see how much it moves. So I'm going to give it a couple bumps. You don't want to overdo this because you can't go backwards, because if you loosen it up, the crush sleeve has already been squashed, so it doesn't spring back. So if you do too much, then you got to take it apart, replace the crush sleeve, and start over again. It seemed like it changed it quite a bit. I'm afraid if I did 2 more times, it might be a little much. Like I said, you gotta sneak up on this. You don't want to overdo it. We're close. We're right about 20. So I'm gonna roll the dice. I'm gonna go 1 more blap. So let's just give it 1 blap. Pretty good right there. 25 foot-pounds. That's pretty close there. I'm happy with that. A couple inch-pounds you're not gonna notice. But the tighter it is, it's just gonna create more friction. So it's gonna cause more heat, which will probably whine and have other issues. But where we're at on this thing, it'll be, I mean, we got dry bearings that are new. So we put some lube in there and stuff. It'll be, that's right on. That's good. That turned out nice. So now we're gonna prep our carrier. This is a used carrier. It's the original one out of that rear end. It is a limited slip, so that's why it's getting reused, but we are putting new bearings on it. So we have our new carrier bearings. We're gonna put our bearings on here. We already wiped this. It's clean. We're gonna get our lube out, put a little lube on our bearing on the inside here where it's gonna go on. And we're gonna do it the same way as we started to do the pinion. We're gonna put it on something solid. This bearing actually goes past the carrier. So if you use something flat, it would stop at the carrier before it installed it all the way on. And then you wanna just push on the inner race, not on the cage. So you wouldn't wanna use anything flat because it would hit the cage. And these aren't quite as tight, so they're easier to drive on. But you can go to the press them on if you wanted to, go that route. So now that is driven all the way on, we wipe off our lube here. You can see how the bearing, it's just barely, but it does go recessed from the carrier. 2 reasons: you don't want to use something flat because you'll push on the cage, you'll hit the cage, and then it won't drive it on all the way because of the carrier. So we want to go on something that pushes on just the race. So now we have this one installed, so when we flip it to beat the other side on, then we're going to be pushing on the carrier, not on the bearing. So make sure that you put the taper to the up so you can slide your race over it, because if you put it on this way, then you can't get the race on there. So just make sure the rounded part should go to the carrier. Make sure we're pushing on the inner race and we're going to drive it on there. Oh, nice and solid, all the way on there. And you can see that this is the same, so it doesn't matter which way you go. The bearings are on past the carrier. It's not like this one's recessed and this one's not. They're both the same. Okay, so now we're gonna take our race, put it on our bearing, make sure that we have this cleaned up where the bolts are gonna go. There's no debris anywhere. We're gonna hold our race. We're gonna flip it over here onto the bench. So now it's sitting on the bench and we can spin it. Then we'll take our other race, make sure it's clean, no prep, put it on here. And so now we can hold it and spin it, right? And you wonder why I wanna spin it. So now we're gonna put our ring gear on here. And this is such a tight fit. This is a machined precision fit. And a lot of people put this on here, and then they use the bolts, because you can see how it doesn't go all the way down flat. So people will use the bolts and they'll draw it down, but you have the risk of taking a little bit of material here or here and getting it underneath the ring gear and actually causing this gear to be a little cocked on there, and it's gonna mess up your pattern on your rear end gear. So what we're gonna do is we're gonna set this on here. We'll make sure it's all clean. We have nothing on there. We're gonna set this here. So we're just gonna use the weight of the gear. And now we're gonna heat this up with a torch and we're gonna spin it. And it's gonna expand to the point where it's gonna fall down and sit flat. So if you don't have a torch, there's a couple different ways. You can put it in the oven, which I don't know how your significant other would feel about that. Hot day, you can leave it out in the sun for a while. We'll get it pretty close. It's about the only other ways you could do it. We're gonna use a torch. We're torching it, so we're gonna fire this bad boy up. So I'm just gonna heat up the ring gear, come around and warm it up. I don't wanna go too fast because I want it to actually heat. It is pretty thick, it's pretty beefy, so it's gonna take a little bit to get it warmed up. Oh, there it goes. So I prepped the bolts. I put some Loctite on here. We can get a rag here. We're gonna rotate this till we line up. So I just wanna snug a couple down that are opposite to hold the ring gear tight. Gotta be careful, don't touch the ring gear because it's probably a little warm. We're gonna flip this over. So now that you can see that it's lefty tighty. You can see that I have my ratchet running in backwards right now. And that's what tightens the bolts up. So we just work our way around. And now you see that the ring gear is nice and even. We don't have any risk of having any burrs in there, any debris that'll make the ring gear run out of true. So now I'm gonna torque the ring gear bolts. These get torqued to 45 foot-pounds. I set it in the vise here, keep it from flopping. And then I'm gonna also use this screwdriver through the carrier where the pinion goes, where the pin goes. And then I'm gonna torque it. I already have them snugged down, so I'm going straight to 45 foot-pounds. I have it in the reverse position because we're going lefty-tighty right now. Just go around in a circle. Oh, that scared me. Oh, that's what I don't like, the bolts that come with it. So it looks like we're gonna have to run and get some grade 8s. This is a hardware that comes with the bearing kit, which I don't know why they use a chrome low grade lock washer with a grade 8 bolt, but our washer here did not like when we torque to 45 foot-pounds. So we're gonna run really quick, get some grade 8s, and then retorque these, because that's not gonna work. So we got all the bolts installed and torqued. I wound up going with a flat washer because we initially showed the problem that we're having with the low grade 5 lock washers. They were opening up, so we went and got grade 8s, and they did the same exact thing. They actually did it a little bit worse. Had a lot more opening up, so I didn't like the way it was turning out. But we did wind up doing a little trick on this. They're advertised as a 3/8 washer, but they fit really nicely on a 7/16 bolt. And I just want to say that we did get ARPs for this. That is for a 10 bolt and a 12 bolt, which is normally a smaller size bolt, but this is a corporate 10 bolt that has 7/16 bolts. But you can see the ARPs, in a sense, have a flat washer, and they just use Loctite. So you Loctite it, you put the high pressure lube underneath the head, and you torque it the exact same. So this in a nutshell is the same bolt. We did heavier on the Loctite. We have a nice grade 8 hardware flat washer and a grade 8 bolt. It torqued to spec, no problem, feels really good. So I'm not worried about anything happening to it. So now we're gonna take it out of the vise. These are the original shims that came out. We're gonna see if we can use them again. So the radius part of it has a flat part, and then a radius part. The radius part goes towards the case. The flat part will go towards the bearing race. So we already checked our rear end here. It's nice and clean. This is gonna be snug. You want this to be a tight fit. We're gonna get it started here. You gotta really be careful with your fingers. Give it a little tap with the handle of a hammer. Kind of work it down evenly. So I got the caps here, and I just wanted to make a note that you want to keep these side side, so you don't want to flip them. So right side's right side, left side left side. So I prepped these. I put a little ARP lubricant on the threads and on the head. So I don't want to torque these to spec. I can get them close and get an idea. So I'm going to run them down snug. I'm going to do like 35 foot-pounds just to get them close, so I'm not putting a lot of stress on the bolts again and again and again if I got to keep taking them on and off, on and off, on and off. So we got the dial indicator set up here on the ring gear, check backlash. So this is a street driven application, so we're looking between 8 to 12 thousandths of backlash. We have a little more leeway in the caps because these caps will get torqued to 65 foot-pounds, and right now they're only at 35. Depending on where we're at, if we tighten this up a little bit more, we can get there. So we want to hold the pinion to make sure it doesn't turn, go all the way one way. That's roughly 14 thousandths, but we're only at 35 foot-pounds. So now we're going to go ahead and torque these to 65 foot-pounds, and that's going to draw it down, which is going to bring it closer to the pinion gear, and that's going to tighten up the backlash. Hopefully that'll get us down to that 12,000 spec, and then ideally we'll be right on. So now we're, what do we want to call that? So now we're at, didn't lose much, 14 thousandths. So a street-driven backlash, you want between 12 thousandths on the high, 8 thousandths on the low, and if it's more of a performance-oriented, you want between 8 and 6. So this is roughly 14 thousandths. So it's on the high side, so we want to take away 5 thousandths from this side and add it to this side. It's going to take the ring gear, move it over more to engage it into the pinion gear. So the backlash is just the amount of slop, in a sense, that it has in the gear. So if you have this too far over, then it would be no backlash. There's pretty much no room for any oil or anything to get in there. It's just to have space to allow oil and lubricant in there for noise. If you have too much, it's going to whine. If you have too tight, it's going to whine. So now we're going to take it back out, and then we're going to take 5 thousandths off of here. So we're going to measure this one, make this side 5 thousandths less, and add it to this side. Got the shims removed. These are the shims that were in it. So this one is thinner. The whole goal here is to move the ring gear closer to the pinion. So this one is already thinner. I was hoping it was thicker and I could just flip them, but that's not the case. So I took away roughly 5 thousandths from this side. So the shim that was in there is 234 thousandths. So this is the shims that come with it. It's got a step on here to hold the thinner shims, and you can make an assortment. Our assortment is roughly 226 and a half. So we'll call it 227. So that's 6 thousandths. We're gonna move the ring gear closer to the pinion. So now we need to add on the left side to compensate for how much we moved it over. So we have 243,000 shim what was in here. So now we need to add roughly 6 thousandths to that. So we should be around 248. So we're at 249 and a half. We're gonna have a little more preload on the side bearings. I think that's good because we have so many shims in here that they're kind of a waffled, and I don't think I'm squishing them enough to get an accurate measurement. So I'm gonna try, this is gonna be on the left side, and then this is gonna be on the right. These are the old ones. So I'm gonna pop the carrier back up so we can get, wash the fingers. We're gonna get it up here, and we're gonna put that on there. We're gonna put that on there. Make sure all of our shims are inside. And I'm just gonna go ahead and torque it back down to the 65 foot-pounds. We're not crammed over so much that it's bound up, so let's check it again. So it looks to me from this angle, looks like we're at 10 thousandths, which is right in the middle of the 8 to 10 or 8 to 12 street backlash. So I think we're gonna run it there. So I just pulled the caps off really quick, just to double check to make sure the shims are all the way seated and they were in the right position, everything was good. And then I just torqued the caps back down. It does have this little spot of the cap that does hold the shims down, but I just wanna make sure. We're gonna check the pinion to the ring gear pattern and then verify that our pinion depth is correct, which is gonna affect the carrier position. So we have this little marking compound. We just put some on a brush. We're gonna put the marking compound on both sides of the teeth, but we're gonna hold it and worry about the drive pattern. You don't wanna get crazy with this stuff because it doesn't really break down in the gear oil. So we're gonna do about 4 teeth here. Just coat it on both sides, the whole deal. So then I'm just gonna put a preload on the ring gear and I'm gonna act like we're driving. We're going forward right now. We're gonna rotate it all the way around the pinion. And then now that you can see I'm bringing it up to where the marking compound is and you can see the pattern that the ring gear has on it from the pinion gear. You can see that it is centered in the ring gear, so it has a good pattern. I'm happy with that. So if this was off, too high or too low in the ring gear, then you'd have to shim the pinion gear up or down. So now I'm gonna go ahead and get this marking compound cleaned off the ring gear. All right, so before we put the axles in it, we have to put the backing plates on it. So these are the backing plates that were supplied. Get all the bolts started in here before we tighten any of them down. So I already installed new axle bearings in here. Same tool. They stop and hit the bottom out of the housing. I'm gonna put a little bit of wheel bearing grease on here. The fluid level doesn't really come up too high in the tubes and it takes a little bit to get out here and I don't wanna have these all dry. So I was gonna put a little wheel bearing grease in here. This breaks down good in the fluid. Then now I'm gonna put the axle seal in. So I'm gonna do the same thing as I did on the pinion seal. A little brake cleaner on a rag and just make sure it is dried. Then I'm gonna do the same thing on the seal here. Just make sure that spring doesn't come out of there. A little trans gel and I'm gonna go around the lip here. Go ahead and put it in. Get it bottomed out. So now we're gonna grab the axle. These are aftermarket axles. These are Mosier's. Had to get them shorter because of the narrowed rear end. So when we will go in, want to make sure not to beat up too much on the seal. Try to go in as straight as possible. Help it along. Then you grab the flange, line it up in the carrier. We're gonna rotate this back to the center here where we can see the axle. You have to push the axle in far enough so you can slide the C-clip onto the whoops. You don't want to do it that way. So you slide it in far enough so you can slide the C-clip onto the end of the axle, and then you hold it there, and then you slide the axle back, and then the C-clip stays in the spider gear, and that's what holds it in place. So we'll get the other axle and do the same thing. Now we got both of the axles in, both of the C-clips. Axles are pushed back, so now we can slide our pin in, which is crazy because this is the only thing that keeps the world going around. One little bolt. Slide our pin in, and then our bolt comes in here and goes through the pin, and that's what holds the whole world together. Put a dab of Loctite on there. I want to get this as tight as you can get with this little wrench. Get it good and tight. I'm just dumping fluid in it to lube everything and keep it from rusting. I'm not filling it up. Just want to get everything coated. So now that we put some fluid in here, we're going to check it when it's in the vehicle. On the filler plug here is on the side. So once we get it level in the car, we'll double check it before we drive. Just want to get some in there, get everything lubed and keep it from rusting up. So we wipe the surface here. We've got our new gasket, and you either use a gasket or silicone. You don't use both, one or the other. We have our rear end cover all cleaned up. We have our original bolts, and we even have our used limited slip differential lube because this is a factory limited slip rear end. So we'll put our tag back on there so the next person knows. So now we're going to go ahead and snug them all down and torque them to 18 foot-pounds. Now we got the rear end cover all torqued down, all finished. Last thing to do is to put the drums on it. So what I believe causes that is these are new axles and new studs, and when they press them in, they don't fully get pressed straight. So if you have a couple that are a little bit off, then it's hard to get the drum on. So that would be fixed once a wheel is put on here and it is torqued down properly. It'll finish sucking the studs centered or squared to the axle. And another little indicator that you have your pinion depth correct, which makes your carrier ring gear in the correct location, is that you can see with the backing plates and the drums on here that you have the same spacing on both sides of the backing plate, which tells you that the carrier is centered in the rear end, which makes the axles even on both sides. So that is how you build a GM 10 12 bolt rear end. It's all the same deal. So make sure you go down, like, share, subscribe, give me a comment, come back for the next one.